In this video, we'll understand QLoRA in a simple and practical way. We'll break down quantization, low-rank adapters, how the full QLoRA workflow works, and then look at a BERT example on AG News classification. Along the way, we'll stop for quick quizzes so you can check your understanding. QLoRA stands for Quantized Low-Rank Adapter. It combines two ideas: quantization, which shrinks model weights, and LoRA, which adds small trainable adapter layers. This makes it possible to fine-tune very large models with much less memory and computation, while still keeping performance quite strong. QLoRA is mainly used with open-weight models like Llama, Mistral, and Falcon. The reason is simple: quantization and adapter-based fine-tuning need direct access to the model weights. If the model weights are not openly available, applying QLoRA becomes difficult. Normally, model weights are stored in 16-bit or 32-bit precision, and that takes a lot of memory. Quantization reduces this precision to lower bit formats like 8-bit or even 4-bit. This shrinks model size and often speeds up computation. Advanced methods like NF4 or normal float 4-bit help preserve accuracy even after compression. Now let us look at this in a simple table format. LoRA vs QLoRA. Main practical differences. Here is the main comparison. LoRA improves fine-tuning efficiency by training only adapter layers, but the base model stays in full precision. QLoRA goes one step further by quantizing the base model as well. That means lower memory usage, lower compute needs, and often better practicality on smaller hardware. The second big idea is LoRA, or low-rank adaptation. Instead of fine-tuning every weight in a huge model, LoRA adds small trainable adapter layers, usually inside attention blocks. The original model stays frozen, and only these adapters are updated. This cuts training cost massively. So how does QLoRA work in practice? First, the pre-trained base model is quantized, often to 4-bit. Next, LoRA adapters are inserted into selected layers. Then during fine-tuning, only those adapters are trained while the backbone remains frozen. This is the core reason QLoRA is so efficient. Now that we've covered QLoRA basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What are the two main components combined in QLoRA? The correct answer is quantization and LoRA. QLoRA combines quantization to reduce model size and LoRA adapters to make fine-tuning parameter efficient. Question 2. Why does quantization help? The correct answer is it lowers weight precision. Quantization stores weights in lower precision, like 4-bit or 8-bit, reducing memory usage. Question 3. In LoRA-based fine-tuning, what usually remains frozen? The correct answer is the backbone model. LoRA keeps the main pre-trained model frozen and trains only the small adapter layers. After training, you have two choices. You can merge the adapters into the quantized model for deployment, or keep them separate. Keeping them separate is useful because the same base model can be reused for different tasks by swapping adapters without retraining the full backbone again. Now let's look at the practical example from the article. QLoRA is applied to BERT base for AG News classification. The dataset has 4 classes: World, Sports, Business, and Sci or Tech. This example shows how QLoRA can be used even in a standard text classification pipeline. The implementation follows a clear pipeline. First, required libraries like transformers, datasets, PEFT, bits and bytes, accelerate, and evaluate are installed. Then dependencies are imported, the AG News dataset is loaded and split, and the text is tokenized with padding or truncation up to 128 tokens. After that, the quantized BERT model is loaded, LoRA adapters are applied, and training is started. In the example, the model is trained with a batch size of 8, learning rate of 5e-5, and 2 epochs for quick results. Accuracy is used as the evaluation metric. After training, the model is tested on sample news text and predicts labels like business, sports, CI or tech, and world. Now that we've covered workflow and example, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. In QLoRA, which part is usually updated during training? The correct answer is only the adapters. QLoRA keeps the backbone frozen and fine-tunes only the LoRa adapter layers. Question 2. What was the example dataset used in the article? The correct answer is AG News. The practical implementation in the article used AG News for text classification. Question 3. Which statement best describes QLoRA compared with LoRa? The correct answer is QLoRA quantizes the base model too. That is the key added idea in QLoRA, LoRa adapters plus quantized base weights. QLoRA is useful in many real-world cases. It can adapt general models for domains like medicine, law, or finance. It also helps with instruction tuning, conversational AI, and deployment on laptops or smaller GPUs. This makes large model fine-tuning accessible to more developers, researchers, and students. The biggest advantages of QLoRA are memory efficiency, lower compute cost, preserved pre-trained knowledge, and flexible deployment with reusable adapters. But there are also limitations. Very low precision can hurt accuracy, some tasks may still need full fine-tuning, and managing quantization plus adapters can add implementation complexity. Now that we've covered use cases and trade-offs, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which is a major advantage of QLoRA? The correct answer is, it enables efficient fine-tuning. QLoRA is designed to fine-tune large models with much lower memory and computation requirements. Question 2. Which is a limitation mentioned in the article? The correct answer is, extremely low precision can reduce accuracy. The article notes that compressing below 4-bit can hurt model quality. Question 3. Why might someone keep adapters separate after training? The correct answer is, to reuse them across tasks. Separate adapters can be swapped or reused for different tasks without changing the base model. That's it for this lesson on QLoRA. If you understood how quantization and low-rank adapters work together, you already have the core idea. Keep exploring and try implementing a small QLoRA pipeline yourself for hands-on learning.